Let's now dive into incredible curious facts about space and astronomy. Let's start. Number 1. How space travel transforms the human body. Welcome to the cosmic journey. Today, we're diving into how space affects the human body. An exciting but challenging frontier, space poses unique challenges to our physiology. When astronauts venture into space, gravity, or the lack thereof, begins to play tricks on the body. The most immediate change is to the spine. Without gravity, it stretches. This might sound great, but it comes with pain and potential long-term issues. Without Earth's gravity, astronauts often grow up to 2 inches taller, which isn't permanent. Another intriguing effect is on the fluids in the body. In microgravity, fluids move upwards, causing astronauts to have puffy faces and thinner legs. This fluid shift also pressures the eyes and changes their shape, potentially impairing vision. Researchers are studying these changes for impacts on long-duration space missions. Muscle atrophy is another significant concern. Without the need to fight gravity, muscles weaken and shrink. Astronauts must exercise regularly to counteract this effect. Bone density also takes a hit. The lack of gravity means bones don't work as hard, leading to density losses, similar to osteoporosis. On the cardiovascular front, the heart doesn't have to work as hard to pump blood, which leads to a decrease in muscle mass in the heart itself. Radiation is another serious hazard in space. Without Earth's atmosphere for protection, exposure to cosmic rays increases, raising the risk of radiation sickness or even cancer. Furthermore, isolation and confinement can affect mental health. The small, enclosed spaces and distance from Earth can lead to feelings of isolation and stress. Despite these challenges, the human body is remarkably adaptable. Scientists and astronauts work tirelessly to understand and mitigate these effects for safe and extended space travel. Thank you for joining us on this stellar exploration. Understanding how space affects the human body not only helps astronauts but also enhances our knowledge of human physiology in extreme conditions. Number 2. How telescopes expanded our universe. Welcome to a journey through the cosmos, where we uncover how telescopes transformed our understanding of the universe. In the past, our ancestors gazed at the stars with wonder, using only their naked eyes. Then came the invention of the telescope, a pivotal moment that changed everything in astronomy. Galileo, often credited with its creation, used the telescope to challenge the Earth-centered model of the universe. Through his lens, he discovered moons orbiting Jupiter, proving not everything revolved around Earth. This ignited a revolution, prompting scientists to question and explore beyond accepted beliefs. As telescopes evolved, so did their capabilities, allowing us to see further and with greater clarity. With each new development, from refracting to reflecting to radio telescopes, our view expanded deeper into the cosmos. The Hubble Space Telescope, launched in 1990, brought us breathtaking images of distant galaxies and nebulae. Its observations have helped us understand the rate of expansion of the universe and the existence of dark energy. Ground-based observatories like Chile's ALMA explore the universe through radio waves, peering into the dusty corners of space. These observations help us map out the birthplaces of stars and the formation of planetary systems. As technology advances, so too will telescopes, promising even more discoveries about our mysterious universe. Join us next time as we delve deeper into the technologies that will drive future explorations into the cosmos. Number 3. Unveiling the mystery of dark matter. Welcome to today's exploration, where we dive deep into one of the universe's greatest mysteries, dark matter. This elusive substance makes up about 85% of the total mass of the universe. Scientists first inferred the existence of dark matter from the gravitational effects it seems to have on visible matter. Unlike stars and galaxies that emit light, dark matter does not interact with electromagnetic forces. This means it doesn't emit, absorb, or reflect light, making it completely invisible and detectable only through its gravitational influence. But why is it so important? Dark matter plays a crucial role in the structure and evolution of the universe. It acts like an invisible scaffold that holds galaxies together and prevents them from flying apart as they spin. The evidence for dark matter comes from various observations, including the rotational speeds of galaxies. Galaxies rotate faster than can be accounted for by the gravitational pull of their visible matter alone. Another piece of evidence is the way light bends as it travels through the universe, a phenomenon known as gravitational lensing. This bending is far too strong if only visible matter were present. Cosmologists also study the cosmic microwave background radiation, which provides insights into the conditions of the early universe. The patterns observed suggest that dark matter was influential in forming the cosmic structure. Despite these observations, the true nature of dark matter remains unknown. Researchers have proposed several candidates, including weakly interacting massive particles, or WIMPs, and axions. Large-scale experiments are currently underway to detect these particles. Detectors buried deep underground or submerged in tanks of liquid xenon attempt to capture signs of dark matter particles as they pass through Earth. Another approach is to look for indirect signs of dark matter through cosmic rays, which might reveal the presence of dark matter through unique energy signatures. The search for dark matter is not just about understanding what it is, but also about understanding the fundamental properties of the universe. What is out there affects everything we see. And yet, every discovery about dark matter seems to lead to more questions. Does dark matter interact with itself? How does it influence the formation and fate of galaxies? As we continue to peer into the cosmos, each observation sharpens our image of the universe but deepens the mystery of dark matter. Our quest for understanding continues to be one of the most thrilling adventures in science. Thank you for joining us on this journey through the shadows of the cosmos. Stay curious, and keep looking up, as the mystery of dark matter unfolds with every new discovery. Number 4. Exploring the cosmos, the epic journey of the Voyager probes. Welcome to our journey through the cosmos as we explore the incredible history of the Voyager probes, humanity's most distant messengers. In 1977, NASA launched two spacecraft, Voyager 1 and Voyager 2, designed to explore the outer planets. Their mission was groundbreaking, to study Jupiter, Saturn, Uranus, and Neptune, providing first-ever close-up photos and vital scientific data. Voyager 2 was the first to launch, on August 20, 1977, followed by Voyager 1 just a few weeks later, on September 5. Despite their names, Voyager 1 would eventually pass Voyager 2 in space. As they ventured into space, the Voyagers carried golden records containing sounds, music, and images selected to portray the diversity of life on Earth. Voyager 1 reached Jupiter in March 1979, sending back stunning images of the giant planet and its moons. Discoveries included volcanic activity on the moon Io. Voyager 2 arrived at Jupiter in July 1979, and later at Saturn in 1981. It too enriched our understanding of these massive systems, their rings, and moons. The probe's trajectories were designed for a possible grand tour of the outer planets, a plan that hinged on a rare planetary alignment occurring every 176 years. Voyager 1's close approach to Saturn's moon Titan redirected its path out of the solar system. It was a calculated slingshot to push it towards interstellar space. Voyager 2 continued on to Uranus in 1986 and Neptune in 1989, each encounter providing more firsts in human knowledge of the outer solar system. By 1998, Voyager 1 became the farthest human-made object from Earth, surpassing Pioneer 10. Today, it continues its journey outward, over 14 billion miles away. In 2012, Voyager 1 entered interstellar space, making it the first human-made object to leave the solar system. Voyager 2 crossed this boundary in 2018. Now in their extended mission, the Voyager probes continue to relay important scientific data back to Earth. Their power sources may last until about 2025. As we look ahead, the legacy of the Voyagers is secure, continuing to inspire questions and curiosity about the vastness of space. Their journey reminds us of the boundless wonder of exploration. Number 5. Understanding solar eclipses and safe observation techniques. Welcome to our journey into the cosmos as we explore the fascinating phenomenon of solar eclipses. Today, we'll uncover what a solar eclipse is and how you can safely observe this celestial event. A solar eclipse occurs when the moon passes between the Earth and the Sun, casting a shadow on Earth's surface and partially or totally blocking the Sun's light in some areas. This rare event is a striking spectacle for skywatchers, but it's crucial to understand the types of solar eclipses: total, partial, and annular. Each offers a unique visual experience. During a total solar eclipse, the moon completely covers the sun. Observers in the path of totality experience darkness as if it were night, revealing the sun's corona. A partial solar eclipse happens when only a part of the sun is obscured by the moon. It can be seen over a much wider area than the total eclipse, but the sun remains partially visible. The annular eclipse is when the moon is farthest from Earth. It doesn't completely cover the sun, creating a stunning ring of fire effect around the moon. Now, observing a solar eclipse requires caution. The sun's rays can cause severe eye damage if viewed directly without proper protection. To safely watch a solar eclipse, you must use eclipse glasses. These special glasses are equipped with solar filters that block harmful ultraviolet, infrared, and intense visible light. Another safe method is the pinhole projector. This DIY tool projects the image of the sun onto a surface, allowing you to watch the eclipse indirectly. You can also use a telescope with a solar filter or binoculars with solar filters to view the eclipse. Make sure these filters are specifically designed for solar viewing. Weather conditions play a crucial role in observing a solar eclipse. Clear skies are ideal. Be prepared to travel if necessary, to places predicted to have the best viewing conditions. Remember, the path of totality is where you can experience the full magnificence of a total solar eclipse. This path is usually narrow and varies with each eclipse. Local astronomy clubs and science centers often organize viewing events for solar eclipses. These events can provide access to specialized viewing equipment and expert guidance. As we look forward to the next solar eclipse, remember that this is more than just a rare event, it's a breathtaking reminder of our place in the vast cosmos. Thank you for joining us in exploring how to observe a solar eclipse safely. Stay curious and keep looking up, as the skies are always ready to reveal their secrets. Leave your comment about the facts, leave your like, subscribe to the channel, and see you in the next video.